In part 3 of lecture 6, we will discuss arrays as parameters. There have been many times when we have wanted to set a variable with an initial value, and we have seen that it is not difficult at all. Obviously, we may want to do the same thing with an array, but not just one value, all of its values. We can set up an entire array with a complete set of initial values, and it's fairly easy. As you can see on the slide, we start off the definition of an array in the same way as we did before. The data type, the open and close brackets, and the name of the array. But after the equal sign, we have a set of values inside curly braces that are separated by commas. This will give us an array of 3 values with the indices 0, 1, and 2. Age sub 0 will be 2, age sub 1 will be 12, and age sub 2 will be 1. Arrays are a very special type of object, and they have some things in common with the other types of objects that we have seen before. In the example on the slide, we can tell that the name of the array is x, and when we write equals new int 10, that is where we set up storage for the array's 10 elements. Being an object, that means that there can be properties and methods. Using the name x by itself will give us the location of the object's data. Java normally passes parameters by value. This means that it copies the value into the space set aside for it in the memory space belonging to the method. Since I am working with a copy of the value, the actual parameter, the value in the main method or any other method that is doing the calling, would be unchanged. But it's different for arrays and other kinds of objects. What gets passed is a reference, the address at which the data is stored. Since the method works with the original copy of arrays and other objects, those changes are seen by the main method or any other method calling the method in question. It's also important to keep in mind that x and x sub I are different. The first refers to the entire array by its starting address, while x sub I is the value of the ith member of the array. Hence, f of x sees the array's reference getting passed. The method being called can use any member of the array, and the changes that are made are seen by whatever is calling the method. On the other hand, x sub I is a single value, and f of x sub I will be used in the method f, but any changes made to it will not be known by whatever method called it. Our program begins, as usual, with import Java util scanner. The header for the class is public class second array, and the comment tells us that this will demonstrate how passing array parameters works. Public static void main string args, and then we declare the array. Int open close bracket x equals curly brace 1, 2, 3, 4 close brace semicolon. First, we're going to use a scalar parameter, myfunc of x sub 0. And in the loop, we'll have for int I equals 0, I is less than x dot length, I plus plus, system.out.print, a blank space followed by x sub I. And then we'll call systemoutprintln to take us to the next line. Secondly, we use the array parameter and call myfunc of x. For int I equals 0, I is less than x dot length, I plus system out print blank space followed by x sub I. and then to take us to the next line, system out println. On this slide, you'll see the two methods both named myfunc. The first one, public static void myfunc int open close brackets a, will then print afterwards, this is the array method. And then for int I equals 0, I is less than a dot length, I plus plus, a sub I equals 5 times the sum of I plus 1. The other one, the scalar one, simply says, will print, this is the scalar method, and then a equals 99. Arrays, like all other types of objects, cannot be compared in the manner in which we compare single data items, like integers and doubles. We cannot use the equals equals operator. All that it would tell you is whether they have the same references, the same address pointing to the same data collection. This means that the programmer needs to write an equals method. The program ArrayEquals will give us the opportunity to test a couple different ways of comparing arrays. We begin public class ArrayEquals. There will be no input, so we don't need scanner. Public static void main, string args, and then int open close brackets x equals new int 10, and after the comma, y equals new int 10. And in this regard, we can set up both arrays at once. Int I, so we declare that variable. For I equals 0, I is less than x dot length, I plus plus, x sub I equals I. For I equals 0, I is less than y dot length, I plus plus, yi equals I. So we now have two arrays with the exact same data. If x equals y, system out println, x and y are equal by, quote, equals equals, unquote. Else, system out println, x and y are not equal by, quote, equals equals, unquote. In this regard, we know whether or not the two are going to be equal or not. What we have left in the program is a test of the method ArrayEquals. If array equals xy, system out println, x and y are equal by, quote, equals array, unquote. Else, system out println, x and y are not equal by equals array. We still have to see how the array works, and that's going to be coming up right away. The method begins public static boolean array equals int brackets a, int brackets b. So we are going to take in two arrays a and b, and we will return true if they are equal and false if they're not. The first thing we have here is if a dot length is not equal to b dot length, return false. If the arrays are not the same length, they cannot be the same. Now for loop. For int I equals 0, I is less than a dot length, I plus plus. If a sub I is not equal to b sub I, return false. Beyond the loop, we have return true. If we run into a single pair of corresponding elements that are not equal, obviously the arrays can't be equal. If we make it all the way to the end without returning false, it must be because they're true. And we see the result of the output. X and Y, being two different arrays with matching data, are not equal based on equals equals. Their references are different. They are in different parts of memory. X and Y are equal by equals array because we know that all the elements are the same. We have been calling our programs using BlueJ, but in many cases it may be necessary to start a program using a command line interface where you would type in a command. Java handles this in a straightforward way. It passes to the main method an array of strings, where these strings are the words typed on the command line immediately after the name of the program. And like any other array, we can use its length property. The program consists of one for loop, where it prints out one command line parameter per line. This illustrates how these command line parameters can be accessed. This is usually the case where you are working on a system that supports Java software development and has a command line interface.